Welcome to my inaugural exhibit hall speech. I've done this in other places, but never within the exhibit hall at Supercomputing, and mostly because I'm pinch hitting for Scott Schultz, who got called off to do the exhibitor forum. Anyway, let's see how this goes, because this is not my standard presentation. I'm doing one at 5 o'clock with more technical information over at Red Hat at 5 p.m. So anyway, Mellanox has partnered with DDN for the longest time. We support fast storage. Well, we do fast storage with DDN using our interconnect. We do have the honor of being the supplier for the top 3 systems in this edition of the top 500. And not only do we have the fastest 2 machines in the US, we have the fastest top machine, the fastest machine in 11 other countries, including China. They took away that slide. China, Canada, Japan, and several others that I don't remember off the top of my head. But if you want real HPC interconnect, you would go with Mellanox. What we're showing this year is that HDR is real, and you can see a live demo across this aisle. We have a couple servers connected through a switch, running at 200 gigabits per second, real, actual. So the thing is, HPC and AI do need the most intelligent interconnect, and what we're putting into both the switches and the HCAs is computational power. We're offloading computation and let the CPUs do their thing, and the network can help with that. Systems with HDR already. The one system that's already installed with HDR is Great Lakes at the University of Michigan, and coming up is Frontera at TAC and Corona at Lawrence Livermore. So those are the next 2 large systems that will have the ConnectX-6 adapter and the quantum switch, in addition to these high-speed cables. So what Mellanox has been doing with code design over the last few years is offloading things that the CPU shouldn't need to be doing into the network. The switches and the HCAs do help with the MPI offloads. So, things like collectives, tag matching, rendezvous protocols, etc. That's all offloaded into the network, and it does help. Just last night I ran CASTEP, and adding hardware collectives reduced the runtime by 40%. So instead of keeping the CPUs doing busy work, we do that in the network. And for that, we have components to accelerate MPI. We have Sharp for hardware aggregation and reduction protocol. There's Shield for self-healing interconnects. If there's fault tolerance we're putting fault tolerance into the network. There's GPU Direct for support of GPUs, and for storage we have the NVMe over Fabrics, and we have Socket Direct, which is what we're currently running the HDR HCAs across the aisle with. This is I'll skip this because I'm sort of running out of time. So Sharp, a recent benchmark they ran at Ohio State showed that Sharp actually reduces, with a relatively small number of nodes, 8, the latency of this mini benchmark AMR. Also, Sharp helps to support parameter serving for training agents in AI applications. So you use less of your CPUs serving parameters for AI applications because that can be done now in the network. So ResNet using NCCL to the NVIDIA convolution, the library, is already optimized for AI. Without Sharp, with Sharp, it improves performance by 16%, and that's only on 8 nodes. So, for artificial intelligence applications, which is all the rage these days, customers are getting more money out, more bang for their buck, essentially. So 60% higher return on investment and 50% lower expenditures. We help applications across the board in all sorts of different fields, and we support all platforms. We support x86, we support IBM's Open Power, we support NVIDIA's GPUs, we support ARM, and we support other people's FPGAs. And I ran too fast.